Okay, so good afternoon, everyone. So lab test was yesterday. We will talk after the class about any concern about the lab test 1. So let us now today continue the class. So as usual, we review the topic we covered in the previous lecture. So previous lecture we discussed mixing static and non-static fields inside the class, and we mentioned that normally class that you're going to create, it's contain mixed. So some fields are statics, bare class, and some fields are non-static. That means they are bare objects. So whenever you create a new object, you will have a new copy on these fields. But the static fields are bare class. That means all the objects, they have the same copy. And also we discussed utility class, and we mentioned that you need sometimes in your application, you design some application, let's say you design application for a car factory like lab test. So you need some tools, some methods, but you don't need to create an object to use these methods. So we rely on the utility class. We closed with the utility class, but we didn't complete. We're going to complete it today. Now, what we're going to cover today is a list of very long topics, but I don't think we're going to cover all of them, but we will try. We're going to revisit the utility class, finalize it. We're going to give an overview what is the array utility class. And we will discuss, I bring these two topics because I saw that it's according to assuming that the students, they know what is the character, what is the string classes. They sometimes forget about a little bit of things. And that's why today we will try to highlight the most important things about the character and string classes and how we can use them, because we rely on them on this course that you master these two classes. Also, I bring these topics, which is the number system, from my experience on the last semester, that students, they notify me that they not aware of what we mean by the number system. So I will bring this topic because we rely on it and we're going to use it later on. So we're going to cover some information about the number systems that we have in our life. And also we will discuss using generics and interface. We will hope, but if we couldn't, this topic will be shifted to the next lecture. So we closed last time with very simple utility class example that we have Einstein famous mass energy equivalence equations, and we would like to implement these equations. So implementing this equation, we don't need to create an object to do this implementation. We go through some steps how we can implement the Einstein mass energy equivalence equations. And we say M stands for the mass in kilograms, C is the speed of the light, E is the energy. We come up with this implementation. We say we're going to have a class, name is Relativity, and we define what we hope is a constant, and which is actually a constant because it has public, static, that means it's a pair class. Final, once we assign the value to this double variable, nobody can change it. So C is the speed of the light, and it's final. Then we have only one method inside our relativity class, and this method is mass energy. It's receive one argument, double as a mass, then is do the calculation, which is simply mass times the speed of light square. And you can see we access the speed of light using the relativity.c, which is the name of the class and C is the name of the static variable. So that's why we say the static field are class variable. We can access it with using class. Look at the definition of public class relativity. You can see that this class does not have any constructors. So based on our previous discussion on the previous lectures, if we define a class without any constructors, can we create an object? Because constructor is responsible to create an object from the class. So now our relativity class does not have a constructor. So we have assuming that we will not create an object. Is that true? Or still we can create an object? Yes, that's true. We still can create object from this relativity, even we're not providing explicitly a constructor to do this task for us. Why? Because Java gonna give us default constructors, and there is some information about the default constructor. Is no argument constructors. There's no argument, and the name of the constructor will be the same name of class. So this is one of the things we're gonna take care of today. So as you can see here, we are using the relativity class inside the main as a test. We create mass with 001, and we send it using relativity.massEnergy. This is the name of the method, and we use the name of the class, and we access this method. Why we are able to access this method using the name of the class? Because it's a static method. That's true. And we print out the energy. Now, we mentioned that it's legal. Yes, it's illegal to, but it's what they call it is consider a bad form to access public static attribute using an object, which means create a relativity object, then access the speed of the light, which is exactly given here on this example. We can create a new relativity. Why? Because Java give us the implicit constructor, which is the default constructor with no argument. So this is legal. New relativity, we can still create an object. You see here in this example, we create a relativity object, and we assign it to the variable y of type relativity. Then we access y.c. It's legal, but it's bad. Okay? We should not allow client to create an object from utility class. To prevent client from creating an object from a utility class, we will provide a private constructor. We will see that later. But now let us discuss the final. We discussed this in the previous lectures. This final has a magic. Final with method. We can use final with the method. We can use final with the field. We can use the final with the class. The magic for the final is different where you are putting it. If you're putting it in the front of the class, you cannot extend it. You cannot create a subclass from it. Final in front of the method, you cannot override it. Final in the field, that means this field is constant. Nobody can change it. And this is an example here. We bring it back is the speed of the light is type is a primitive type, it's double, and it's final, and it's static. That means it's bare class, public. Everybody can access this field. Okay. Normally, we use public static final for a constant. We have to be careful. We mentioned last time that we have to be careful. Using final with a mutable object is very dangerous effect. You could have some side effect. You assume that you define final with a mutable object that this is a final state. No. The only final in this case is the address that is assigned where the object is stored in the memory, but the state of the object, the client can't change it. So in this example, we can see we define public static final fraction half, and we create a new fraction with the assumption that a fraction class is created, and we give numerator and denominator value 1 over 2. So now we have final. This is the name of the variable. This is the final. But the state of the object, which is the fraction object, is not fixed. So if you are using this inside the main and you give the immutator method, which is the set method, set denominator equal to 3, this is legal and this can work. And in this case, you define in your application final half, but unfortunately the client was able to change it. It's become 1 over 3. So we have to be careful when we are using final with immutable type or immutable objects. So this is exactly what happened on the memory. You define final half is at address 700. So 700 is fixed. This is the final. This is final. But the 1 over 2, 1 and 2, which is numerator and denominator, these are not final because these are the state of the object. And the object in our case is a fraction. So the user or the client can go and still use half.set denominators and change the value of 2 to 3. So this is final. The reference 700, address 700 is final, but numerator, denominator are not final. Okay? Any question? Okay. So we mentioned that still we can have a new relativity. So the client can create a new object from our utility class. That means we didn't complete the job. So we need to provide the private constructors, so the client will not be able to create an object. So if you leave the definition as you saw in the previous slides, the user still can do new relativity. And it's legal, no doubt about it. Why? Because the definition is not complete. So how we can complete the definition? We provide the utility class with the private constructors and empty constructors, okay, that hide the way we can construct the object from the client. So making the constructor private is simply saying to the client, you cannot create an object from this class. This class, you cannot create an object from this class. So private field, private constructor, private method can only be used inside the class. So once we define a private field, client cannot access it. Private method, client cannot access it. When we say a private constructor, client cannot access the constructor, which has an effect that means the client cannot create an object. So to complete the definition, and we can say this relativity class is a utility class, we have to provide a private relativity, no arguments, no implementation inside the body. So in this case, the client will not be able to create an object. Okay? Any question? So as you can see, just to summarize, the utility class is a class, contains some set of statics fields, and some of these fields are finals, and static fields, that mean they are beta class, and also some set of static methods. And we mentioned on the previous lecture that a static method can only access a static fields. Okay, so you cannot access non-static field using a static method. So if the utility class contains all the static fields, it should contain all static methods. Okay, so prevent creating an object is simply providing a private, empty, no argument constructor inside your class. Okay, so we close the utility class topic. We start a new topic today, is array. And what we are addressing today is a utility class of array. But before we jump to discuss the utility methods that Java expert provided for us to work with arrays, let me just give you a small background information about what is array and how we construct array, how we access array. So we have a utility class array, and inside this utility class we have a lot of useful methods that we can use with the primitive types except booleans and with any other array of objects. So only boolean have a special treatment on the array, but we have a utility class called arrays, and inside it we have a lot of methods that Java expert provided for us to manipulate an array of any objects and also of any primitive type except boolean. So we can overload different version inside it. So you can use a binary search for array of integer, binary search for array of characters, binary search for array of string. So that's what we mean by overloading version inside these arrays utility. The system also have arrays copy methods that copy the element from a specific part of array to another part, which is very useful to construct array not from scratch. You can rely on a previous array that is already constructed in your application, and you construct a new array either to short the size or to extend the size of the array, because array, once you create the array in your application and you said that this array of 5 elements, it's fixed. The only way to extend the size is to create a new one and copy the previous one inside it, okay? Either to short or extend the array. This is the link where you can read more about the arrays utility class, and you have a lot of set of methods there for more details. Now, just as an introduction or the background information, you can see here int, square brackets to indicate that this type, this object is called the variable myArray1 of type of an array. And okay, this is myArray1 of type array. Array is an object. So what is I can store inside this object? I say equal in new int 7, which means I ask the compiler to go to the memory and reserve 7 spaces. And okay, how much the size of each space? The compiler will look at the type, oh, int. So I will reserve the size of int. Maybe the size of int is 4 bytes, 6 bytes, 8 bytes. Okay, it's always power of 2. So we reserve the space based on the architecture of the machine. And the index start from 0. So we have 7 spaces, start from 0 up to 6. Now, we have index and we have the value stored at that place. The index 0, the value is 69. The index 1, the value is 61. And go on until you have the index number 6, is the value is 9. So whenever you create an array, you have to determine how many spaces you need and what the type of these spaces. In this case, we have 7 spaces and the type is int. Now, I create, if I just say double and put square bracket, that means I create an array type of double. This is the object type, declaration type, and I give a name, double array. I didn't reserve anything. The compiler will understand, yes, you will have double array as a variable in your application or your program, but you didn't assign any space to it. Once I say double array is equal to new double 10, that means I'm saying now, yes, now this double array will point to the array of type doubles inside the memory, whereas I reserve 10 spaces, and the size for each space is the double space. Okay? Now I can use double array, and I give square bracket 0 to access the first element, up to 9 to access the last element. This is how the array is defined. Okay? Once the array is defined, you can think about double.length as a readable fields, because as I mentioned, array is an object. So any object has some fields. So one of the famous fields that is coming with an array is the length of this array. This is a readable object. You cannot set the length. You can only get the length. You can read the length. So in this case, double array dot length will retain 9 or 10. 10. We retain 10 because we have 10 elements, 10 spaces, okay? And this is readable only. We cannot change it. We cannot set. Say double array dot length is equal to 11. I'm assuming that I will increase the length of array by 1. No. This is once you create it and say new double of 10, it will set the value for double dot length, and this value will be equal to 10. Now, how I can go over the element inside my array? That is the iterating. The method, the old-fashioned one, is go from for loop, define int is equal to 0, semicolon, I less than the array length, semicolon, I plus 1. So this is the increment the index by 1. Until I reach the array length, I will stop, then I will go and visit each element. I will represent my index, my array 1, and the square bracket, and inside them the I. That means I'm accessing the value at that index. So this is the old fashion of going through the element inside your array. So as again, this is just for documentation. We already talked about it. This is very important that once you define the array, that attribute or the field length is set. You cannot go after that, extend the array or shrink the array unless if you create a new one and use a copy method to copy the array, either use your own method or rely on a utility class to copy it for you. So array.length is readable only, and it's set once you are using the new double and you specify the size of the space for the array. This will be set. You cannot change it. Another way to go over the element of array, and you are interested only on the value. You're not interested on the index where this value is located. I'm interested on the values, okay? But normally, when you go over the values inside your array, you go sequentially, okay? You cannot jump, okay? Unless if you go to the index and say index plus 2, not like, look here in the previous slide, we say plus plus. That means I is jumped by 1 positions, I plus plus. You can jump by 2 positions by say I plus 2. So you can jump by 2 positions. You skip 1, okay? Now, if you are interested on the value, you can use this method. So you just say, oh, my array 2 is of type int. So I say int I, then I put colon and the name of array. So the Java here will understand you're going to go over all the values inside your array. So you don't interested on the index. You're just interested to pick the value. Sometimes I need to go to the value and check if this value is a prime, even, or odd. I don't care where is this value at which index. So I can go over the array. And this is one-dimensional array. You can do it for two-dimensional array. But remember, in two-dimensional array, okay, you have the rows, and each row is actually a one-dimensional array. Okay, so you have, let's say, 4 by 4 or 4 by 5. So you have 4 rows, and each row is actually one-dimensional array of columns. Okay, so in this case, you go to my two-dimensional array, and you say, give me the rows. I put them as an array. Then inside J, inside I is also an array. This is the inner loop is exactly the same as this one-dimensional array. But the outer loop is a little bit different because you are retaining a column. And each column is actually what? An array object. Okay? Because it's a two-dimensional array. If it's three-dimensional array, I can believe you can imagine how you can do this. Okay? So just 2 square brackets next to each other. That means this is a two-dimensional array, and then you put the loop for three-dimensional array. This is how we can iterate inside the array. Now, it's very important to keep in your mind, array is not a variable, it's an object. So that's why we said at the beginning of this course that everything on Java pass by value even for the reference. We pass the address where the object is stored in case if we are passing an object. So in this case, when we are treating the array is an object. So we are sending an object. Look at this example. We have pass by value and reference. So A here is int, and the second argument is int of type of array. So B is a type as an argument of an array. So inside this, it's retain void, it's a static, and inside it, we change the value for A. A is a local variable, but B of 0 is 77. B is actually an object. So we access the first element of the array and we change it to 77. Okay? Did you see that difference here? We're passing the primitive type. We mask it by the value, the actual value of a primitive type. But array is actually an object. When we pass an array to that application or a form, or you share your array with somebody else, so you're sharing the reference where the array is stored in the memory, so the client can access the array and change it. Okay? So in this case, we are sharing my array 1 with the pass by value and reference, and this will affect the value of the array. It's a dangerous because client can change the value of the array once he obtained the reference of that array. Okay? Any question? Private, that means he will not be able to access that all. Okay? I mean, you share it. You provide it to him by sending it as an argument. But if you define a private array inside your class, nobody can access. Only within the class you can access. Okay, how we can make a clone of the array? We have .clone method to create a clone of the array. So if we have integer a list and we define the list, here we define a list as an array, and it's contain how many elements? 4 elements. That means a list dot length will be equal to 4, and the element is stored from 0 to 3. And we define another p list as a type of integer array, and now we use a dot clone. This will copy all the element inside the array inside p list. So now we have 2 separate lists of numbers, and they have 2 different handlers. One as a list, the other one is p list. We can create our own deep copy of the array by going through all the elements inside the array and actually creating an object. Let's say you have an array where the store an object of type string. Now you can, in this example, you can take a string out and put whatever object you like. Okay? You can take a string and put dates object. Okay? If you create a class of name is laptop, you can take a string and put your own class. So you can take a string, because a string is an object, and put whatever you like objects. You replace it with any object that you like. So here is the deep copy version for an array of type string. You can see here, before I start, I create a new array. And I create this a new array by giving the same size, okay, of the what? Of the original one. So a new string, and I give original.length. So because I'm doing a deep copy, it's obvious that what I'm copying, if I have an array of 10 elements, the copy should have 10 elements, not more or less. Then I go over all the element inside the length, and I do copy inside this element. Original.1.clone, so I copy it inside it 1 by 1. So I copy the object 1 by 1. This is our own version. Or you can rely on .clone. Okay? Sometimes, if your object is not a primitive type, it's good to do your own deep copy. Yes? Yes, if you are in your class, let's say now it's int. Int is a primitive type. So dot clone it's going to work perfect for us because a primitive type is not object. But in case of you are taking int and replace it with any object, that means you have to look at dot clone for that object. It's implemented or you rely on the default implementation of the Java. So if you rely on the default implementation for the Java, you will have the shallow copy. You will not have the deep copy. Okay? So in case of you are doing dot clone for any arbitrary objects, okay, that you created in your application, you have to be careful on that, and you have to revise, as you mentioned, you have to revisit the clone method and do the implementation for it in the way that you like. Any other question? Yeah, we can explain that in the, by looking to the previous lecture. So after the lecture, I can show you the slides, okay, from the previous lecture, which is explain exactly what the difference between the shallow copy and the deep copy, okay? No, you will not get error because dot clone will what do? Ship, if you remember the header of dot clone, it's retain an object. Okay, it will retain an object. Will inside the clone, you will create an object and you ship it back to the client. So the dot clone will retain an object of type array of int, and will retain it back. Will create that object inside the memory. Will retain the reference and store the reference on plist. Okay, will not have any problem because we didn't initialize how many spaces we need for plist. This is a primitive type. It will be a deep copy because inside the primitive value we store the actual value. So int inside the element number 0 we have 11. We could be 11. Good? But in case if you have an object, you have to be careful. Okay? Just keep it in your mind. Whenever we have a primitive type, what we are storing is storing the actual value. When we say dot clone, we get a deep copy. But if we have any objects that we create inside our application, we have to make sure we implement the clone in the appropriate way that we like. So if we need a shallow copy, we implement the clone as a shallow copy. If we need a deep copy, we implement the clone to do the deep copy. Yes, yes. No, it's a deep copy because of type of primitive type. Int. Int is a deep copy. No, a string is an object. String is not a primitive type. It's an object. And the beauty of a string is an immutable object. Okay, once you create it, you cannot change it. Okay? Any other question? Okay, so sometimes you need to check the array for equality. If this array is equal to another array, so you have to go for loop and compare the element by element for equality. Okay? So here, for example, we have two arrays. We need to check if these two arrays are the same. We have list 1, list 2. First, we check if they have the same length. If they don't have the same length, there's no point of going through the for loop and visiting all the elements. So if you have two arrays with different length, then you retain false. These two arrays are not equal. But if you have two arrays and happen that these two arrays have the same length, then it's now is necessary to go and do visit for each element. As you can see in this for loop, we're visiting all the elements. Once we find at least one element is not equal, we return to the client that this element is, these two arrays not equal. We return false. Okay? That's a check for equality of that. Just one more thing here to highlight. in this case, we are using not equal sign, okay? But if you have an object, what you should do? Dot equals, that's right. We're going to use dot equals, because if we create our own object, we say to make sure that these two objects are equal or not, we're going to override the implementation of equals method. And inside the equal methods, we look for the object if they are equal, and we return to the client if they are equal or not. So there is a limitation with array. Yeah, we're going to come to it. We're going to come to it next lecture. So, I mean, next slide. Okay? About copying the array. There is a limitation for the array. Once you, we already mentioned that. Once you define the array of int with 4 elements, you cannot go and say a dot length. This is not acceptable, because a dot length is readable. You cannot extend the array once you create it. 4 elements, that means 4 elements. Now, arrays will not do equals by itself. You cannot say a1 equal a2, because a1, a2 is storing the reference where the arrays exist. So a1 carrying the address of the memory, a2 is carrying the address of the memory. Maybe a1 is stored at 700, maybe a2 is stored at address 600, but even the elements inside this array are equal, but a1 equal a2 will not give you true, because these two arrays are different space on the memory. We cannot use a1 dot equals a2 even, because a is an object of array. There is no dot equals with that object. Okay, to do the equal of all the element, either to go visit all the element and make sure these elements are equal. Okay. If you want to print the array, array does not know how to print itself. So if you decide to define a1 as an array and you print it, it will print the type of the array and which address. So it will not print the element. Okay? These kind of limitation come with the array. What is? Here. Yes, because Java will understand. In the first one, I just create an array of 4 elements, 4 spaces in the memory, but I didn't give the value. In the second example, I put the curly brackets and give the value. The compiler will understand I need 4 spaces, and this is the value inside these 4 spaces. It's another way to initialize and create an array. Okay, inside the Java, either to create using a new, and you reserve the memory inside how many space you need. Then later on, you can see in the first one, I just create 5 spaces. I don't give any value. In the second, I give the value, and the compiler will understand how many value you give inside the curly brackets. 6 value, 4 values. I will store these values inside the memory, and I will retain the reference to A1. $42 is the value. That is on the A0, A10. What do you mean can't change it? Yes. Once it's created, you can go to A10 and you change it. Once you create the array, you can change it. Okay? This is only declaration for the array, and you give the initial values. But later on in your program, if you decide to change the first element of the array, you can do that. Okay? But this is the initialization. It's like a constructor. You have different kind of constructor. You have a default constructor. We just create an object with default values for the fields. But you have sometimes a customized constructor where it's can create an object with some startup point, some initialized value for the fields. Okay? Here you start creating an array without giving any value, just reserve 4 spaces. But in the second one, I want to create a 4 element array but I give the initial value, but later on I can change these values. Okay? So these are array class, which is the utility class. As you can see, there is a method inside this class, and these all methods are static methods. So we can access this method by what? The arrays dot, you give the name of the method that you like, and you give the appropriate parameter or the argument, so that method can work on this argument. Binary search, you give the array, you give the value that you are looking for, and it will retain the index, or retain the value less than 0 if the value is not exist. But there is a precondition here that the array should be sorted. You have a copy of, you give the array, and you give the length, and it will retain a new copy, a new object. Okay? It will retain an object of type array with the same type of the array that you are looking to copy. Here is equals. Arrays.equals is different. Arrays.equals is a method, is a static method inside the utility class arrays. You give two arrays, and it will retain true or false if these two arrays are equal. You have fill. Sometimes you need to fill all the array. Array is like 1 million items. You need to fill them with the same value or some value or something. You use fill. Sort. You take the array and you sort it out. ToString. That will allow you to print the array out to the user. So array.sort, it will retain the string. Here we define integer e as an array, and we add the element 3 and 4. We store it back to element 1, okay? And we bring the array back. That will retain back the values of the array. We say e is, that is the value for the array. Now, to use the arrays, we have to import java.utility.arrays inside our application. Now, arrays.binary search will allow us to look for an element for all the arrays, and we have different versions: int, doubles, characters, short, long, float, inside the utility class, overloaded. For each different types we have as a primitive type. We don't have a Boolean. We said Boolean is excluded from this. Now, you have the array of type int as a list. You start looking for element 11 inside it. As you can see, list is sorted. And you give this, you access arrays.binary search. You give the name of the array, and you give the element that you are looking for, 11. It will retain number 4. The element, the value that you are looking for is stored at index 4. So 0, 1, 2, 3, 4. Yes, element 4 is equal to 11. Okay. Now, in case if you are looking inside the character string, character array, this is a character array, and you have A, C, G, X, Y, and Z, and you're looking for element T. Element T is not exist. The binary search will retain -4. Why it's retained -4? Because this array is sorted. Where is minus T? If you want to insert T inside this array, where is the location? Here. This is array sorted. Where is the appropriate location to insert T? 0, 1, 2, at 3. So 3 minus 1, this will retain -4. This is what is the value of -4. If someone wondering why I received -4, why is not -100, why is not -1 million? It's written a negative value, but it has a meaning for this negative value. If you have T inside this array, it should be at location 3. But actually we don't have. That's why we have -4 is retained to us. Okay? So there is a preconditions for the binary search to use the binary search. One, this precondition that should be sorted in increasing order. So if you are using an array of any arbitrary object, that means you have to look at that object and make sure you have compare to is implemented. Okay? And the compare to sort the order of the object in increasing order. So, yes, if you have T, this is array does not contain T, yes? It's sorted. Where you should insert T? If I told you insert T, where you should insert it? Here at the end? You should look, this is sorted. It's T come after A, T come after C, T come after G. It should before x, yes? So it should be here. And what is the value for this index? 0, 1, 2, 3. So 3 minus 3 minus minus 1, it will be minus 4. Okay? It always do this kind of calculation where we supposed to see t, and we take that minus 1. Okay? I just explain it for you. Sometimes students ask questions, why we have minus 5? Why we're not having minus 1,000? Because the requirement is retaining a negative value, but the Java expert, when they implement this method, they implement in such a way, it's retaining a negative value where you're supposed to see the field, or where you're supposed to see your object. I'm supposed to see the object at index 3, but unfortunately I don't find it, so I have minus 3 minus 1, I will return to user minus 4. It will not put a value. A binary search will not insert anything. It's just finding. So you see the first example, we look for 11. 11 at which index? It returns 4. Okay? Now, there is an array and there is an array list. Array list is a collection type. There is advantage about the array list. It can extend automatically. Okay? As you saw, the array, once you create it, is fixed. You cannot extend it. So it can grow in the size, and it has a lot of useful methods that we can rely on. When we cover the collections, we will gonna visit the array list on details, and we discuss all the equations or all the methods that we are using. Okay, any questions about array? It's supposed these slides is supposed to refresh your memory about the background information about the array, and introduce arrays as a utility class where you can use it inside your labs and inside the lab test. Now, character and string, these two famous arrays. I'm going to go quickly over these slides because these are also our background materials, but I would like to refresh your memory and remind you with some useful methods come with these classes. So you know that a character is an object, not a car. C at AR with C is a small, but character with a full word with C is capital. This is a wrapping class, is an object class. Okay, and it has a lot of useful method. As you can see, is a digit. You can send a car and ask if this character is digit or not. I mean, from 0 to 9. Okay, and you can ask if it's a letter. You can ask if it's a letter or a digit. It's a lower, it's upper, white space. Okay, or you can change the status of the letter by shipping another. You see here, because these are, you retain an object of type car. You retain an object type car, and you retain an object type car in the last two methods, and they are statics. All these are statics. So these are, that means you can work with the characters as a utility, because all of these are static methods. It's retain a value for you, and you can see in the last things, it's take to upper. It's take the character and retain an upper version of it. So there is also one important thing about the character is called character arithmetics, because inside the computer we use the ASCII code to represent each characters. Okay, so to refresh your memory, A capital is 65. So actually the computer will understand A capital as 65. So you can add A capital plus 1, it will give you 66. So you can do arithmetic with the character, because really the computer will understand the ASCII code for the characters. And you can, there is an ASCII code tables where all the information about the character or the value, the capital start from 65, the small start from different number. So we can do some arithmetics for the characters, okay? Because the computer will understand this character as an ASCII code. It's stored in 1 byte. 1 byte, okay? 8-bit. So you can have random letters. It will use a random generators next int, which retain an integer value between A capital and Z capital, this will retain a value, a capital letter, random. Okay? This will retain a random number. Now, origin is actually, this a variable is a random number. You know how to define random number inside Java? Okay? You define a random number, just import the class, and you ask for next integer, and you provide A capital and Z capital, which will retain to you an integer value, but then you cast it to give the character value. This will generate a random letters for you, capital letters. You also, this is actually what happened inside the is digit. It will take the character and ask if it's greater than 0 or less than 9. Otherwise, will retain false. So this will check if the character is digit. That means it's 0 or 9. Because also 0 will understand based on the ASCII code as an ASCII code inside will not has a value 0, but it has ASCII number representations. Now, one of the main application for the character arithmetic is to take the value, this is an exercise, to implement to hex digit. So I give you the integer value, and you check if this integer value between 0 and 9, you retain 0 and 9. If it's between 10 and 15, you retain A start from 10. So 10 is A, P is 11, C is 12, okay? D is 13, E is 14, F is 15. So we use this, okay, and to build this method. So 2 hex, we receive the integers. That's the first header. We retain the character at the end. We check if the value is greater than 0 and less than 9. So we're going to retain the same value, just the character, and we add the ASCII for the 0. So if we have 0, we will add 0 to the value of, this is a character arithmetic. We have the ASCII for 0. We add 0 to that, so it will retain 0. If we have 1, we add 1 to the ASCII. We retain the ASCII for 1. We retain a character to the user. Else, if the value is greater than 10 and less than 15, we're going to have to add the value that we received minus 10 to the ASCII of A. So if we have the 10, so 10 minus 10 will 0. 0 added to the ASCII of A capital will retain A capital to the user. I recommend all of you to go back after this lectures, take this inside the Java, put it inside a class, and run it and see how you will have the output. Okay? Else, we retain the question mark based on the exercise. If the value was out of the range, we retain the question mark. This is how we take the integer value and we check the integer value and we retain the hex characters. Now, if we go to the string, is another very useful class, and there's a lot of useful methods inside the string class. Okay, so all these, we discuss all of this information. I put it in the slide for the documentation. You have the immutable object for the string. You know this. String is built by the Java technician, Java programmer built it for us. We use it, and it contains a lot of useful information. So if you think about string, you can think about it as an array of characters. So whenever you define a string hello world, is actually spreaded inside the memory as an array. It starts from 0 to 11. So because a string is actually an array of characters. Okay, so this array of characters is stored inside the memory as a string objects. Length is fixed, and you can retain any character at each index. In this case, for example, you have hello world, and you can say string dot character at, and you retain the character at index 7 or 0 or 11, as long as you give the index within the length of that string. How to check the string are equal? You cannot say equal equal. S1 is equal to S2. This is wrong. Okay? You have to use what? Dot equals to make sure that these two strings are equal, because string is an object. Now you can just to comparing between the character and string, or you have to rely on compare to. So if you want to compare two string, S1 dot compare to S2, that will retain 0 if these two strings are equal, less than if S1 is less than S2, and greater than if S1 is greater than S2. Search inside the string. You can give me the index of H, give me the index of O, give me the index of ELL. Okay? You can search inside the string. You can search inside the string using the method index of. So you can search inside the string. You give a start of. You can start looking from index, okay, 5, starting positions. Then you please go start from index 5, start looking for an index of string or value of O inside our string. This also a list of very useful methods. Last index of, you give a character, give me the last index, you see this character inside the string. Equals, sometimes we need to make sure that these two strings are equal, but with given that we're going to ignore the case sensitivity of these capital or small or mixed. So we use start with, if your string is start with some string, end with some string, replace, sometimes you need to go for a string and replace some kind of character inside your string. You need to cut the string, retain another string. Okay, this is called a factory methods because it's retain an object. Okay, and two lowercase, also another factory method because it's retain what? A string. And also two uppercase is take a string and retain the uppercase for all the characters inside the string, and this is all the factory method. All the methods that retain a string are factory methods, and we say we rely on the factory methods once we decide to create immutable objects. Okay, and string, one of the famous examples for immutable objects. Any question? Again, the previous slides about the character and string, the purpose of these slides is to refresh your memory and remind you about these two very useful classes that we can use later on in the class. Another topic I would like to remind you about is number system. What do you mean by number system? When I say number system, what is coming to your mind? Any suggestions? Number system. Binary and hexadecimal. Octal. Good. Decimal, which is the one is the famous. Okay? The one that we use. Okay? Decimal numbers. Okay? Decimal numbers. All this right. Binary is and binary. All of them is under the what we call is binary systems. Okay? Binary systems, decimals, octals, hexadecimals, and binary. Computer understands zeros and ones. Binary is very important for the computers. But also, sometimes when we do the calculations using pencil and paper and digital logic or other courses, we rely on the hex, because hex is compound representation. 4 bits will equivalent to 1 digit on hex. So binary systems, zeros and ones, octals, base 8. That means we have from 0 to 7. We cannot have a digit of 8. If we have a digit of 8, that means we're going to do carry on. Decimal is the famous one, from 0 to 9. We know how to add with carry, subtract with carry. All of these calculations that we have on the decimal number, we can take it and make it for the binary, make it for the octal, and it's the same thing. It's like method overloading. Addition with decimal, we do another version of addition, but now for the binary systems. We have the hex. Hex is start from 0 up to 15, but after 10, we start using the letters. A, B, C, D, E, and F. F represent 15, A represent 10, and you fill the letters. As we saw in the previous slide, we create actually a function that receive an integer and retain the hex digit. Okay, just to review the decimal numbers, I hope I didn't do any mistakes. Okay, so if we have 537, which means that we have 5 hundredths, that is the digit. That means 5 times 10 to the power 10 plus 3 times 10 to the power 1 plus 7 times 10 to the power 0. Why we are using 10? Why we're not taking 10 and put 9? Because it's a decimal. Any number system in our life has a base. And in decimal, the base number is 10. So that's why the weighting system is coming with the decimal number, saying that the position of the digit, then take it as a power for the base. What's the position for 7? 0. What is the 10 to the power? 0. What's the position for 3? Is 1. 10 to the power 1. What's the position for 5? Is 2. 10 to the power 2. This is the weight system. Okay, that's why we have a ones digit, hundreds, and 10 digits. Okay, and thousands, millions, whatever is there. So then you start putting the values for each digit, and you add them together to have at the end 500 plus 30 plus 7. You take this in the previous lectures or previous course. Actually, we have this from the school. We know it all over. Okay, but the same thing, we're going to apply it for different systems. Okay, the same style here. Okay, the same style to find the weight, the value for this value. We need the weight system. Not only by saying decimal, I implies where is the weight. You already know this from the school. You apply it without even make any sense. Oh, I know, this is at ends, ones, and all of that. But now when we come to the binary, how we can convert binary to decimal, or actually decimal to binary maybe. No, I start from binary. If I give you the representation 101, we're going to apply the same system. That's why I bring this slide. It's the same system of the weight. We are talking about the binary. So what's the base? 2. So 101, 101. So what is the position for 1 from the rightmost? It's 0. So 2 to the power 0, 1 times 2 to the power 0, 0 times 2 to the power 1, plus 1 times 2 to the power 2. So that's the positions for the number. And then we end up with decimal digit is equal to 5. So if I give you the binary number, I go tell you what is the decimal, you're going to say, oh, it's very easy. Give me, what's the weight system? I don't need to give you the weight system. Because it's a binary, you know the base is 2. So the position of the digit, starting from 0, raise it to the power of 2. So here we have the first one at location 0, 2 to the power 0. The second, 2 to the power 1. Third, 2 to the power 2. The positions start from 0. And this is actually, if you have the 0 to 7, that is the byte, 1 byte. Okay? And this is the positions. So the first one is represent 1. The last one is 128. Okay? So if we have 1001001, okay, that is the 8. Okay? 8 digits. How we can find the weight? We start 0 times 1, 0 times 2, 1 times 4, plus 1 times 8, 1 times 16, 0, 0, then 1 times 100. Okay? So we apply the weight system until we got 156. Did you cover binary in the? You covered that, yeah? Just to remind you then. Okay? If you need more information, you can go and visit the online resources and learn more about the decimal. But this is not the main topic of the Java programming. But I bring it out because we're going to use it later on. Now, convert decimal to binary, you have to do some calculations. when you are trying to give you the decimal and I ask you for the binary, you have to do the, sometimes you look at the number 3, so what's the maximum weight is 2, then the remainder is 1, you can come up with 1, 0. But there is a systematic way, is the division way. So let's say I give you 28, you start 28 divided by 2 is equal to what? 14. What's the remainder? You keep it aside. Then 14 divided by 2 is 7. What's the remainder? 0. You keep it aside. Don't throw it away. Just write it down. Okay? Then 7 divided by 2 is 3. The remainder is 1. Keep the remainder aside. Take the quotient is 3. Then use 3 again. 3 divided by 2 is 1 and the remainder is 1. Keep the remainder. Take 1. 1 divided by 2, 0 and the remainder is 1. Now you finish because you reach 0. Now you go backward and read the number. It's 1, 1, 1, 0, 0. This is the representation for 28. Okay? This is how we take the number. Now if I ask you, can we write the Java to implement this? We can. Okay? Can we write the Java to implement the binary to decimal or decimal to binary? We can do that. Okay? We know the method. We can implement it. Okay? This is the hex table where you know that 4 bits in the binary represent 1 digit on the hex. So 0, 0, 0, 0 represent 1. And you can see the table. And there is a link here. You can click on it and read more about the decimal binary hex conversion. So if you have 15, is 1, 1, 1, 1, which is represent F as hex. Okay. Now if I give you the hex and I ask for the binary, it's a very easy task. You don't need to do any calculation. Each digit on the hex represent 4 bits. So 2, 0, 0, 1, 0. A, 1, 0, 1, 0. C is 1, 1, 0, 0. And this is then the number. Just concatenate the definition. So can we write a Java program to do this? Give you the binary, give me the hex, or give you the hex, give me the binary. Simply grouping 4 bits together, give me 1 digit on the hex, or breaking down 1 digit to 4 bits, give me the binary number. No magic, yeah? Good? You can use Windows calculator nowadays to do this for us. Okay? You can even ask, check if your program is correct. You can ask the calculator. You give the binary and then you click on the octal, give you the octal, it give you the decimals. Also, it's good that sometimes it's convert between inverse and do a lot of things now. This is a scientific calculator. In my time, it's only addition and subtraction and multiplication. Nowadays, there's a lot of things you can do with the Windows calculators. Okay? Write the Java program that receive a decimal number and retain the binary number. Okay? So I'm going to give you this, and I would like you to go at home and do this exercise for different number conversions. Okay? Take a decimal and retain. If you are able to retain, do one conversion between decimal to binary, then you can take the binary and generate the octal, because 1 digit in octal is actually 3 bits. 1 digit in hex is actually 4 bits, because 8 is 2 to the power 3. 16 is 2 to the power 4. That's why we have this kind of beauty of taking the binary and move it to octal easily, move it to the hex. And also we can go backward easily. Okay? So you only need to conversion from decimal to binary, then everything will be done. Sometimes people are saying, I will convert to hex, then I can go backward to binary easy because I divide by 16, which is very fast. Okay, you can see here I define int, decimals, remainder, quotient, I is equal to 1, and then I define binary number as an array of 100. I say, whatever you give me as an integer, I will only use 100 bits. Then I receive from the user, I enter the decimal numbers, I enter this, I put it inside the quotient, and I do for loop. So while I have some value inside this field, I will keep looping. I will do the remainder and store the remainder after I divide it by 2 inside binary number, okay? And I keep index I. You see here in the I is equal to 1, okay? Keep the index. Every time I store the remainder and increment the index. Then I divide and store the quotient. As the process is just implement the process that we explained in the previous slide. After we finish, that means we have the quotient is equal to 0. We're going to get out from the loop. We're going to start from the last index that we receive to print the value for the binary number, and we use j is equal to I minus 1. Then as long as j is greater than 0, we're going to continue the printing out the binary number. So if we then we print the end of the line, that's okay. If we send 28, we'll retain 1100. So this is exactly the one that I would like to discuss with you, is taking an integers and retain the binary representation. Now, if I ask you to implement from decimal to octal, you say, okay, why should I do? I take this code and reuse it. Okay, I put it inside the method and I will reuse it. I will ask the user to enter the decimal. Then I will create this as a static method, maybe a utility class. Maybe we can create a utility class that is only do the conversion number system and can do the conversion, and has a static method convert to octal, convert to hex, convert from octal to hex. So it can just a utility class that can help the students to play around with the number system. Yes? Okay. I encourage all of you to do this kind of exercise. Create a utility class where you can convert the number systems. Okay. Any question? Okay. We use the left time to introduce the topic, and we're going to go over it again next lecture. Use the generic and interface. This is now, it's actually one of the very, very important topics, and if the students was able, allow me to say this, digest this topic correctly, he mastered the Java programming. Yes, we need to know the inheritance. Yes, I need to know the recursion later on, but this topic, it's open a door for all of us to use a lot of Java classes that are built by Java expert, because they use the same kind of things, interface, generic. All the collections that you saw on the lab 0, on the lab 2, on lab 1, list, ArrayList, all of them built based on the concept of generics. We build something and we would like to use it for different types. How I can parameterize the class? I create the class and I need to use it for any things. You store it with any object. I create a list as an abstract data types. I can use this list to store any object, chairs, tables, okay, employee, managers, car, trucks, whatever you like. You can store inside this array list or inside the list, hash map, hash list. So this topic is very important, okay? So we're going to start it today, just a motivation about it. We will continue discussing this next time. So let us see this example. It's a motivation example I call. You have an array. We discussed an array, yes? What is array? But now we are using integers, doubles, and characters as a wrapping class. So we define an array of objects here. It's actually, this is an array. Integer array is an array of objects. Each element inside this array is an integer object. Double array, each element inside it is an object of type double. And character array, each element inside it is of type characters. Then I ask to print this array. I need a method, it's called print array. Do you think how many versions should I have to print these arrays? 3 arrays. 3 arrays of 3 different types. There are 3 different objects. I can take integer and put whatever you like as an object. You need to print this array. The only thing I ask is to print the array, please. How many versions of overloading I need? Three. One for integer, one for the double, and one for characters. Actually, I need three. Version of integers, you see the signature because the signature is different. It will receive an argument of type integer array. Receive the argument of the integer array. That is the signature. You see the public static void, the name of the method is the same, but the argument is integer array. Look at the second. The same name, the same public static void, the name, but the signature, the name of the argument is different. Now it's a double. I cannot do this. I have to make an overloading of the method. I have to create a three version of this method to print array. One for the integer, one for the double, one for characters. And I cannot avoid this kind of redundancy. Okay? I have to do this to be able to print the array of integer type, character type, or double type. This is good. No. It should be kind of, because the body are almost the same. Just go over for loop. The concept of the body is the same. Go over all the elements inside the array and print them. Doesn't matter if you have integer or double or a character. Just visit each element and print it out. So the body is the same. This is the output in case of you are using these three methods. You're going to print them out. We solve this problem using generic. We remove this kind of redundancy because this is kind of redundancy. And this is just an example of printing an array. We end up with these three versions of this. We're going to continue next lecture why we need generic. I hope now you have some kind of motivations. So we discuss more in details next lecture.